All right, so we're the virus detection strip automation group. Abdullah, Jacob, Alex, and myself, Jake. Um, yeah, we'll give it a little intro and tell you about our project.
So basically, the virology lab here has been working on a project to test viruses for Montana-specific wheat strains, um, and they made a couple hundred last year, and they want to produce 50,000 this year, 10,000 for each of the five different viruses if they're interested.
Of things like this, works like a works like a pregnancy test. Basically, one end gets wet, flows through all of it. This is just some intro stuff here.
Yeah, we'll be getting the antibodies from the lab, and then we'll be getting materials to make them from GE Healthcare.
Yeah, and currently they were making strips one at a time by hand, which was slow. So we're gonna make it faster.
Automated process.
Right.
So how the system works is, like Jake said, it's a home pregnancy kit. Basically, instead of testing for pregnancy, though, it's testing for a virus, and it's testing wheat. So take a little piece of wheat, put it in a bag, grind it up with the mesh that's in there, and then you stick the strip in. The strip will flow through, and if the virus is present, it will go ahead and leave one of those marker lines.
Yeah.
If no virus is there, no line is made.
Excuse me. So this is basically our process. We're going to get materials from GE, get the antibody solutions, conjugate solutions, basically the stuff we need to make the strips. We're going to pre-assemble it. We'll talk about how this works here right now. So that first step two, I mean, the pre-assemble cut conjugate pad. One of these, I should mention that the conjugate pad is this little chunk right here. So basically, we get these materials from GE. The conjugate pad, release pad, is not the right width. It comes in about 3 times the width we need. So it comes in a roll like this, but we need it in a roll like that. So we take it over here to this machine. You'll place this little roll holder apparatus over here and put a roll of the wide GE stuff on it. Feed it through this cutter block, which is 2 razor blades fixed in place with a bolt and a nut, and then it'll feed it through here and feed it onto these 3 rolls with the crank handle, and crank it all through, and it basically makes 3 rolls out of 1. So it's 3 50-meter rolls. You take one of those rolls, you bring it over here, and then you pre-assemble the conjugate pad onto these cards, which are essentially this strip times 40 running back this direction, and then the cards are cut into these little strips back and forth.
So at this point we have the white center part on there, and then also the orange part. And then we'll take the cards and we'll run them through the printer.
Yep, we'll print those antibody and the conjugate solutions on there. So 3 lines of printing, and this little our printer should work. That's one of the kind of the research part of this. But basically, this is a feeder here that acts as a hopper for more cards. So we can just put a big stack in there instead of 30 or so. We can hold like a couple hundred. And then also as a guide, it acts as a guide so that the cards run straight through the printer versus hitting one of the rollers and turning sideways and creating lines that veer off to the side.
And we've done our research. We have an inkjet printer picked out for this, and we should be able to simply place the conjugate inside the different ink cartridges.
Yeah, a refillable cartridge will be used. 3 of them will be used in here. So we can refill them with the conjugate. And we're using a piezoelectric inkjet printer versus a thermal, just to make sure that we don't harm the antibodies running through the printer. So then those cards come off the printer and they run into this jig here, which assembles the last 2 parts of this card. That'd be the sample pad and the absorption pad, basically 2 thicker pads. The only reason we don't do that before printing is because, well, it'd cause problems with feeding and stuff. So we're just going to leave that off. Those pads are thicker, so they'll cause problems with feeding in the printer. So we'll assemble those there, and this guillotine cutter serves as basically a chop block, cuts them off to length. And then we take those cards, we wait 24 hours for the adhesive to cure, and then it runs. Then we'll run it through the shredder. Right before we run it through the shredder, though, we got to cut them in half. So that's this guide here, and then they go through the shredder where they are cut. Now we don't know any output dimensions for the shredder yet. So this little apparatus here is essentially just a sheet metal part that will serve to pull those strips down into like a little bin and point them all the right direction. But we don't know any of the dimensions, so it's just kind of a general shape right now. We'll work those dimensions out once we get the shredder and can measure it.
And then we'll package them up, and they'll be ready to go.
Mm-hmm. We also analyze this process from a throughput standpoint. So we did analysis on this process to find how fast we can put all of our stuff through here. So some of these steps, take a per card unit of time, which translates into man hours. Some of them just take hours, and then weight hours, and it's broken down into those two categories. Obviously, man hours you get paid for, or you have to pay for. Weight hours you don't. So per 10,000 strips, it comes out to about 8 hours. So one set of strips per virus you can do in just over a workday, and one set of 50,000 strips, so the entire bunch you can do in just over a work week, which is perfect. And that's 2 cents a strip, which is perfect. That's a really low labor cost for this process. Economically, you run those with materials and everything. We were shooting for under $1 a strip, and we came out to 15 cents a strip. So we're doing good. It worked out perfectly in that regard. Yeah, there's our project.
Yeah, thanks for listening.